Already, GIS stands for Geographic Information System. Basically, it's a combination of three words. That is geographic. It gives you the location of your data. The second word is the information. That is the uh, data that is attached to your location, and this could be in the form of tables or attributes that gives you further insight to your location. And the third word is the system. So that is many components working together to achieve a goal. It basically comprises of hardware, networks, software, and operational procedures, right? So this is GIS. So if we give define GIS, so that is GIS is a computerized system for capturing, storing, checking, integrating, manipulating, analyzing, and displaying data related to positions on the Earth's surface. No, the GIS is not a new term. This concept has been previously used. For example, the map overlay technique that is most frequently used in GIS. This has been used in the previous times as well. Uh, for example, the French cartographer Louis Alexander, he used this technique to study the movements of the troops. So this is not a new concept, but the term GIS first appeared in literature in the mid of 1960s, but some of his techniques they have been used in the past as well. Now, the map overlay technique is basically you place different maps of the same area, giving you different features, one on the top of the other, and then you analyze for different field conditions. Uh, For example, there could be a maps that is showing the parcels, boundaries of a certain place, then soil type of a certain place, wetlands, land covers. Uh, so when you place these maps one on the top of the other, then you go for different types of analysis depending upon your requirement. Now, GIS is basically is composed of five components: software, data, methods that you use for analysis, and then the people that that uses that, and then there is the hardware. Now, what can I do with GIS? There are a lot of things that you can do with GIS. You can view the imagery. You can create 3D models of certain places. Then you can create maps. Maps, they can be broadly classified into two categories: reference maps that are the general maps that gives you directions of a certain place. Then there are thematic maps that are special purpose maps. For instance, a survey map of a certain place, right? That could be for a special purpose. And you can perform other tasks, like you can calculate the area, you can calculate the volume, you can go for different types of analysis, like you can plot the contours, you can go for the hill shade, view shade. So these are different features that you can do while using the GIS. Now, the key components of the GIS, so basically, there are three key components: computer that composed of hardware, software for capturing, storing, and processing and analyzing your data. Then there is geospatial data that is in the form of maps, aerial photographs, and satellite images or statistical tables. And then you have users for design of standards or for analysis and updating and implementation. Now, why there is a need for a GIS? Uh, because the old maps that are in the hard form, they are poorly maintained, right? If you have to update an old map that is in the form of piece of paper, right, then you'll have to do it all over again, and it is difficult to update them. Then they are also not very accurate, and once you have to share that information, you cannot do that easily. So these are mm, some points that pushes us to go for GIS. Now, the disadvantages of the old techniques, these are the benefits of the GIS. For instance, you can easily maintain the data, right? You can easily go for revision. You don't have to plot all over again. You just need to introduce the new data into the old version. So once you have digitized the map, you can easily go for update at any time, and you can easily convert it into different scales. That is not an issue. It is easy to share from one point to the other point. So they are similarly a lot of time and money it will be saved, and also it helps you in better decision making. You will see there are some examples at the end that how GIS helps you in making better decisions. No, there are a lot of GIS softwares that are in practice. For example, ISRI, ArcInfo, ArcView. Then we have GRAS information systems. Then there is Autodesk ArcMap. ILWIS, that is the integrated land and water information system. So these are different softwares that are included in GIS. Now, GIS is a multidisciplinary science that can be applied to a number of aspects of our daily life. For instance, it could be applied to different it could be used in geography, statistics, cartography, that is the art of making the maps, urban planning, geodesy, civil engineering, surveying, uh, and in environmental engineering. So this is applicable to a number of sciences. It is not only restricted to civil engineering. These are the applications of GIS. Like you can use it in facilities management, environmental and natural source management, in case of forests, right? In order to have a better look over the crops, right? And in case of disaster management, you can apply this as well. Then street network planning and engineering, that is dam projects, urban planning, regional planning, land information system, border of revenue, that can use it. So there are a number of applications of that. Uh, Next is the GIS data sources. Now, two basic data classifications that are used in GIS are spatial data and non-spatial data. We will discuss that in the coming slide, what is spatial data and what is non-spatial data. Now, the GIS data, it can be collected from a number of sources. Either you can collect it directly by going in the field, that is the field surveying, that you must be familiar that you can use a total station or a third light or a GPS. You can go in the field and you can directly collect it from the field. And then we have remotely sensed images like aerial photographs and satellite imagery. You can use that, or if there are existing topographic maps, you can use them after digitizing them. And also you can utilize data available from the government agencies. So there are a number of ways. Either you can go collect it directly from the field, or if there is some data available to you, you can use that. Next is the georeferencing. Now, georeferencing is basically you have to find a way to relate geospatial data to the surface of the earth. ठीक है, जब आप अपने डाटा को relate कर देते हैं surface of the earth के साथ, that is called the georeferencing, right? For that, we need to, first of all, we need to decide about the shape of the earth. No, most widely accepted shape of the earth, that is the ellipsoid. And then you have to transfer this 3D shape onto a 2D paper with minimal distortion. For there are a number of projections, as you can see in the figures. Depending upon your purpose, you can select any of these. Of course, all of these has some errors, some distortions when you convert 3D into 2D. Now, what is a spatial data? Spatial data is basically it gives you the coordinates, it gives you the location. So spatial data consists in general of natural and cultural features that can be shown with lines and symbols or seen as images on photographs. So spatial data, it gives you the location of certain features. Now, how can you represent spatial objects? So there are a number of ways. For instance, you can use points, right? The points uh, can be used to show houses, wells, mines, or bridges. That can be represented by points. Then there are lines and strings. If you have linear features, like you can use these lines to represent roads, streams, fences, property lines. And then you have interior areas that is composed of enclosed by three or four lines. No, they can be used to represent government jurisdictions, parcels of land ownership, different types of land covers, or large buildings. Or if you have an area, then you will have to show it by the interior areas. Uh, then we have pixels and grid cells. The pixels are usually tiny squares that represent the smallest elements into which a digital image is divided, right? Uh, Assigning a numerical value to each pixel specifies the distribution of colors or tones throughout the images. Uh, Pixels, as we already know, that it represents dots per square inch. Then the other option is to go for the grid cells. The grid cells are single elements, usually square within a continuous geographic variable. Similar to pixels, their sizes can be varied, with smaller cells yielding improved resolution. ठीक है जी? This is the diagram that is showing you all the five options. For example, points, lines and strings, interior area, that is combination of three or four lines. Then we have pixels, and then we have grid cells. As you can see, these grid cells, these values 2, 5, uh, and 9, they are representing certain features. For example, 2 can be showing you sandy soil, 5 can be showing you a marshy soil, 9 can be showing you gravelly soil. So you code it accordingly. No, there are two formats to represent the spatial data. One is the vector format and the other is the raster format. Now, in vector format, you represent it in the form of lines, points, and polygons. Okay? Raster data is shown in the form of the uh, grid cells, या pixels. And the third thing is the attributables. That is the additional information that is giving you about a particular feature. Now, for instance, uh, you can see in this figure A, that is giving you the region using standards topographic symbols. In this figure, you can see that there is a forest, right? And then this marshy land, and then there is grassy land. No, there are two ways to represent this map. Either in vector format, that is in the form of points, lines, and polygons, and second is in the raster formats, that is using the grid cells. Now, the figure B, that is showing you the vector representation, right? They have marked the boundaries using the lines, right? So as you can see over here, if I can, this thing, over here, that is this boundary is representing the forest, and then we have the marshy land, and this over here is the grassy land, right? And our line is also indicating the stream over there. So this is the vector representation of the geography of your map. The raster, in raster, you will represent it in the form of grid cells. As you can see, F stands for forest, S stands for sand, right? S stands for stream, rather, and G stands for grassy land. No, the more finer this mesh, the more accurate it will be. But the other thing is that if you go for more finer mesh, then it will require more space. This is again the same thing, the data types, vectors and raster, right? In vector, you present it in the form of points, lines, and polygons. And in raster, you go for the uh, pixels and grid cells. This is vector data type showing you the polygons and points represent polygons represent certain area, and the points represents important features that are there in that area. And these are the lines that may be showing you the road networks, right? Or any streams, you can also show that with the help of the lines. And this is the raster representation of the same thing, in which you are representing that in the form of the pixels. Now, raster data that could include images, elevation models, and scan maps, right? This is the hillshare map, right? Now, then we have the data attribute table. Now, this attribute table, this gives you an additional information about a particular feature. Now, this could be used for querying and analysis. For instance, let's say this is a map of a certain area, right? You can attach to this polygon over here, you can attach an attribute table that could be anything. For instance, it could be showing you the population of that particular area, right? It could be showing you the details about the schools in that particular area, or the number of colleges, or the number of hospitals. Any additional information that you, any information that you want to attach, you can attach to this uh, uh, to the attribute table. Then topology is basically a branch of mathematics that describes how spatial objects they can be related to one another, right? So there are three types of topologies. First one is the connectivity that gives you the information from where chains are connected. For example, from which node to which node. Agency, agency shows that which spatial features, that is point lines and areas, are adjacent to chains and polygons. And then there is containment to determine these which spatial features, that is the points, lines, and small polygons, are enclosed within a specified polygon. So there are three types of topologies: connectivity, agency, and containment. You can use these three to describe the relationship among different features. Then there is the non-spatial data. Non-spatial data basically is that which does not give you the coordinates or location of a certain thing. That could be, for example, in the form of a table that you attach that gives you information about that particular feature. For example, as I have already shown you this thing, this table over here, this table. Now, this is your attribute table. You can attach any information associated with this polygon to this. So non-spatially data is basically that data that gives you now that doesn't give specifies the location of anything, but it gives you extra information. For example, if you have if you have brought a property at a certain place, then that will be the spatial data, that property, because it have a location. But the additional information, like what was the buying cost of that property, or if you have sell it, what was the cost of that, that what is the total area of that property. So that is the non spatial data. Then spatial data format conversion, as we know that they are two formats. First is the vector, and then there is the raster. Now you can represent the spatial data either in vector format or in the raster format. Then you also have the option to go from one system to the other system. Like instance, for if you have the vector, then you can convert it to raster, right? Now if you have to convert the vector to raster, right, uh, then you have to go for coding. Uh, like vector to raster conversion is also known as the coding and can be accomplished in several ways. Now, there are three techniques for this. First is the predominant coding, that whichever value is dominant, you associate that particular feature with that dominant dominant property. Second is the precedence coding, that you give importance to certain features and you coordinate it accordingly. The third is the center point coding. In center point coding, whichever value is in the center, you go for that. Uh, I will explain this with the help of an example. Let's say this is, let's say this is a map that is available in vector format, and you have to convert it into raster. Now there are three techniques for that. First one is the predominant coding. For instance, let us take this example. Now this thing over here, this is representing a cell that is having third row and first column. This is third row and this is first column. This cell, we are talking about this cell, right? Now as you can see, the major portion of this cell that is composed of forest, so that's why they have named it after forest, as you can see that over here. This is F over here. Why? Because the major portion of the cell is comprised of the forest, so that's why they have named it against the forest, that is F. F stands for forest, so that is the predominant type. Second is the precedence type, that you give preference to certain things. For example, if there is a stream in a certain map, then that is the most important feature, or you can categorize it yourself. For example, if you give the higher value to a streams and you are going for the precedence coding, then if you take this example, if you take the cell that is the fourth column and fourth row and third column, this one over here, this one. No, since you have categorized stream as the, you have given higher value to the stream, and since in this cell stream is appearing, although the major portion is of marshy land, but you have given more importance to the stream, so that's why you have categorized it as S. The third is the center point method, whichever value is there in the center, you name the cell according to that. For instance, this second row and third column, this cell, right? Now as you can see in the center there is marshy land, so they have represented it M. So these are the three techniques which you can follow for conversion from a vector to raster image. Then similarly can also convert from your raster to vector. uh, this is again the same map, and this is the raster version of that, and you need to convert it into vectors. So what you do is that you identify the boundaries, like you can see over here that if I can enter it over here, these are the cells that are representing the boundaries, right? Now you mark these boundaries, right? And at the end you just simply join these by straight lines, and that will give you your required result, that is conversion from raster to vector. Now of course this will be depending upon and your meshing over here. The more fine the meshing, the more accurate will be your result. Now, why we go for spatial data? The reason is that it is available everywhere due to social media and GPS now available. Uh, now, as I already told you, what is spatial data? Because spatial data is that gives you the locations and shapes of geographic features and the relationships between them, usually stored as coordinates and topology. Or if you broadly want to define that, then you can define it any data that can be mapped, that is called the spatial data. Examples of this spatial data is an Excel file with addresses that gives you location, a picture with coordinates, That is again an example of spatial data. An image of a map, since that is giving you a location, so that is again that. Then different formats, for example, if it is in vector form, then it is stored in the form of shape files. And if it is in tabular form, then you can represent it as you can store it as in form of excel files. And then the raster images that are stored as geotiff or jpg images, right? Then softwares that are used for viewing spatial data is GIS, ArcGIS, online mapping software में ArcGIS, online भी आ जाता है, statistical and data visualization software. Then we have programming languages, Python, MATLAB है. Now, this is a picture that is giving you a map of certain area, and the question being asked is that whether this is a spatial data or not. And the answer to this is yes, this is a spatial data because it gives you the road maps of the Boston area. Now, is this a spatial data? This figure again, this is a spatial data as well, because it is a scan map of the Boston area. And then they have this ice cream cup in front of you, and he's asking that whether this is a spatial data or not. The answer could be yes and no. Yes, if it is if the coordinates of this ice cream cup is given to you, then it will be a spatial data. But if the coordinates are not given, then that will not be a spatial data. ठीक है जी. As you can see, yes, when an image is georeferenced to a map or has embedded coordinates, then that is called the then you will call it as a spatial data. Now, then this is again an example in which it is showing you that whether he's asking that he's showing you a table that is giving you information of different types of businesses, right? And their amounts, and he's asking that whether this is a spatial data or not. And the answer to that is not, because he hasn't provided any location with reference to this where these businesses are. So that is not a spatial data. Or rather, it will be non-spatial data, because it is not giving you any location. Then creating GIS database. No, you have to create your database prior if you want to perform any analysis on that. Because unless or until you will not be collecting any data, you will not be able to perform a certain analysis on that. Now, data source may, as I have already told you, that generating digital data from field surveys, you can go in the field, you can use your GPS or total station or any other technique, and you can collect the data from there. Then you can go for aerial photographs. If there are some existing maps, you can digitize those, and you can use them as a source of data. Or if there's some existing digital data sets, you can use that. For instance, if there is like survey department of Pakistan, you can obtain information from them. Over here, an example of US geology survey is given. So they must have a department over there, and you can go there and you can collect the data. And other option is you can go for remote sensing images या मोबाइल मैपिंग के लिए. ठीक है, इसमें scanners and lidars are the examples. Now, no, this GIS data that could be used over a number of fields or a number of branches. For instance, GIS software programs usually support both raster and vector models, as I have already told you, and some programs readily convert from one to the other using the techniques that we discussed above. And you can use this data in different fields, like you can go for elevation data, parcel boundaries, hydrology, transportation, soil types, geology. You can use it in different aspects of our daily life. Characteristics of GIS में data, this is of two types, spatial Non-spatial, and then there is the non-spatial is also called is tabular data. ठीक है, मेथड्स में डाटा इनपुट आप किस तरह से करते हैं, डाटा को मैनेज कैसे कर रहे हैं, एनालिसिस के लिए कौन सी टेक्निक यूज़ कर रहे हैं, और आउटपुट आपको किस फॉर्म में चाहिए, मैप्स की फॉर्म में चाहिए या नया टेबल आप जनरेट करना चाह रहे हैं. This is basically showing you the technique in which the polygons they are used uh, place one over the others to create maps and perform analysis. So this is the this is you have introduced lines, and the lines they may be representing the node road networks, right? You have introduced lines over the polygons, and then you can also introduce points that will be giving you the important features. So you can keep on adding and you can keep on updating your map. So this is the flexibility of the GIS. Right, this is the map overlay technique that is in which different maps of the same area showing the different features, they are placed one on the top of the others, and you attach to these certain features in the form of tabular tables, right? And then you go for your analysis or your query that you generate. Now this is an example that is showing you mm, the different accidents that occur at a certain place over a certain period of time, and they have attached the informations like the location of those accidents, right, and the data that which type of vehicle was involved at which time those incidents took place, what were the age group of people that were involved in those accidents. After performing analysis, they could use it for a number of purposes. For instance, they could use it to reduce uh, the number of accidents by analyzing which are the critical situations over there, which are the critical timings, and the solution can be either they can introduce some more traffic signals, or they could install more traffic personnel over there at those critical times and at those critical places to reduce the accidents. So this is how GIS helps you in decision making over complex scenarios. Metadata is the additional information that you provide. It gives you the information like when that data was created, what were the limitations, when that data were collected, and what were the recent updation, what were the recent updates that they have included over the period of times in that data. Then there's metadata standards, means in which format, if you want to introduce the metadata, then there is a certain format for that, and you have to introduce it according to that format. This is again an example of they have uh, Los Angeles River Revitalization Master Plan. They want to introduce the recreational opportunities for the people over that were living nearby that, uh, and they use this GIS technique to help them in better decision making, that which were the critical points at which they can introduce that with the minimum possible cost. Uh, this is various steps that they went for that. For example, first of all, they created an map that was showing that river. Then they created a buffer around that river line, that at how much it will be the area surrounding that will be affected by this project, right? And then they introduce another thing, that what are the already existing parks over there, like these green circles, these are representing those, and then they subtracted the area influenced by those parks, and then they decided that this much is the amount of area that we need to consider. And then they went for different options, like what were the different age group of people that were living in that vicinity that would be benefited from that. And then finally they concluded that okay, this is these are the locations which will be most suitable if you want to give benefit to the people that are there at the minimum possible cost. So this is basically an example telling you that how GIS helps out in complex decision making. And then this is some other examples where GIS can be used, like preliminary mapping, animal tracking. This can also be used by using GIS can be used over here. They monitor the movement of the animals around the globe. Then 3D modeling can be done using this GIS technique. Then emergency escape routes. This could also be one of the applications of the GIS. Then this is a slide giving you information about the US flights around the world. There is a website that is giving you information about the schedule and timings of different flights that are at different places of the earth at different intervals of time. So this was pretty much the uh, all the information regarding the GIS. Now, all of you must be having some questions.